depending upon the machines and the equipments given, the service factor came out to be 1.5, and we got the rated motor power as 41.65, and we selected a standard motor of 45 kilowatt, for which we are having a design power of 67.5 kilowatt. We are assuming number of teeth on pinion as 25, module as M, which makes the pitch circle diameter of pinion as 25 m, peripheral velocity of pinion as 1.88 m, and the static force used for transmission of power as PD by Vp, which is 35.9 upon m kilonewtons. And then we selected these two materials, SA1045 for pinion and cast steel heat treated for gear. Although the value of S0 for SA1045 is higher than that of gear, but when we work out to check which material is stronger, so we are talking about whether gear or pinion is stronger, wherein we take into account its material plus the tooth geometry, which again depends upon number of teeth on pinion and gear. From the formula given in the design data book, we came out with the value S0 into Y for pinion is less than S0 into Y for gear, and hence we are designing it for the pinion. So with this quick recap, now we'll start with our calculations. Please keep your design data book ready. Next, we have to start with getting what is FB. What is the formula for FB? Beam strength. Vaishnavi?
Ma'am, S0 Y BM CV.
B into M. And when do we use CV? Or why do we use CV? Atharva?
CV takes care of the incremental load Fi.
Yes. So as of now, since the value of Fi is not known, we'll consider CV and we can equate this value equal to Ft. So that is the concept. S0 for pinion is known. How much? 210. Value of Y for pinion is 0.37. The value of B, you can refer the design data book. The value of B is given in what range? Turn the pages. What is the value of B given? It's on table 16.7, page 169 as per my design data book. What is the range of B given? Atul? Value of B should lie between. Atul Jamkar, are you there?
Yes.
8.5 to 12.5 times of M. So this is the range of B. We have to assume some value between this. So normally we'll go with 10 times of M. Okay, so this is the value that we'll be using. So S0 is 210, Y is 0.37, B is 10 times of M. M is M. What about CV? The value of CV is given in terms of VP. But VP value is not known, that is again in terms of M. So if now I go up as 4.5 upon 4.5 plus VP, this equation will become too complicated. So there is another way of getting the value of CV which depends only upon the RPM. So if our pinion is rotating at 1440 RPM, what is the value of CV that we assume? As per the discussion in the last class, 0.3. So we assume the value of CV as 0.3 without using the formula because value of VP is not known, and this is because N is greater than 1000 RPM and it is less than 2000 RPM. Once we get module, once we get value of VP, we'll calculate what is the actual value of CV and then we'll compare it with this CV. Give me this value in terms of M square, something into M square. Yeah, what is the value of M square? $777.3, 233.1. Yes, this is the value. You are right, Ambika. 233 M square. This is the value for FT, FB. And this is in what units? Y is unitless, S0 is unitless, M is in millimeter square and S0 is given in megapascal. So what is the unit for this? Newton or meganewton? Vineet?
Meganewton, that's what I wrote.
No, it's Newton. Value of S0 is in megapascal, where megapascal is this value 210 Newton per meter square into 10 raised to 6. Right? And mm square is in millimeters and millimeters. Newton per meter square and millimeter square. This will cancel each other to give the value in Newton. Is that correct? Megapascal is actually Newton per millimeter square and this is millimeter square. So this value is in Newtons. Agreed? Vineet and Shravya? Good. Now since we have taken this CV value, we are already taken into account that because of incremental load, the beam strength is only 30% of the total beam strength, which means we have reduced it by 70%. And so we are equating this FB with FT. So this FB should be greater than or equal to FT. We are doing this because we want the value of M module. What is FT in terms of M? We calculated in the last class. We are taking it equal to FT. And what is FT?
35.9 into 10 power 3 by M.
Right. So this is 35.9. This is in kilonewton. So we convert this also in Newton. That's the reason I wrote it like this by N. Now from here you have to give me the value of module. Give me what is M. $5.36. Very good, Atharva. This is 5.36 or 5.37. Again, refer the data book and tell me what is the next available value of module as per the preferred choice. 6. So we'll go with module as 6. Now once we know the value of M, we'll get the value of B, we'll get the value of DP, we'll get the value of VP. And now once we have all these values, because everything was initially taken in terms of M, once you get VP, we'll check what is CV by formula as given in the design data book and whether our CV selected was correct. So if M is 6, what is DP? It's 11. What is 11? DP is 150 mm. What is VP? Okay, you're telling me the value of VP, 11.28 units meter per second. Now, if you have VP from the design data book, what is the value of CV that we are taking? Refer the design data book table number 16.3 for the velocity lying in the range of 7.5 to 15, which is the class 2 carefully cut gears. The formula for CV is 4.5 upon 4.5 plus BP, which gets a value 0.285. What was the assumed value? It was 0.3. And what is the actual value? It is 0.285. Is this better than 0.3 or it is worse than 0.3? What do you say? What do you understand by this value of CV coming out to be less than the assumed value of CV? CV by calculation is coming out to be less than CV assumed. What is the meaning of this? If you understand what is CV, then you understand what is the meaning of this. Anyone please? 0.3 is better. 0.3 when you are assuming that there is 70% incremental force coming into picture. So the beam strength is only 30% of that. Whereas here the calculated value is saying that it is 28%, which means 72% goes as incremental load. So higher the value of CV, better is the beam strength. Lower the value, lesser becomes the beam strength. That is the meaning of the value of CV. Okay, so this is just for an understanding, and this is also giving you this velocity rise in the class 2 category of gear. Now let us check out with the value of FB as per the calculation. So your FB, which we have equated equal to FT, which is 35.9 into 10 cube by M. Use this, or better use 233 into M square. You know the value of M. 233 M square, where M is 6. This is equal to S naught remains the same. Y remains the same. M is same. Value of CV has changed. Give me the value of B. Here we are going to check whether the value of B is lying in the range of 8.5 M to 12 M. 5983 is FB. Give me the value of B. B is coming out to be 63. $59. Why so much variation? CV is 0.285, M is 6. Y remains the same value that we used earlier, 0.466. 0.37, okay. S naught remains the same. Give me the value of B again. Okay, we go with 63. All you need to check is whether this value of B is greater than B minimum. B minimum is 8.5 times M. If this is greater than B minimum, then you are safe. B minimum is 8.5 times M, which we have taken as 6. Is 51. So this is greater than 51. So this is good. This is safe. Now we have to go with value of FD, dynamic load. FD is FT plus FI, incremental load. Now calculate FI. The formula for FI is given. All the values are also known to you, where FI is 21 times VP, known to you. Value of C we get from data book. Error E we get from the graph. Value of B is 63 plus FT, you know, upon 21 VP plus root over C E B plus FT. So your FT and FB, this is 5983. This is known. What is C? Table 16.4. For 20-degree full depth, the materials that we have used is steel and grey cast iron. So what is the value of C? Everyone is expected to answer in the chat box. You are right, Ambika. No, it is not 1180. Ambika, it's not 1180. 8100, yes. 8100 for 20-degree full depth and for the materials in mesh, grey cast iron and steel. So this is C, B, you know. Next is error. So as I said, if we know the class of gear and module, we can use the table for probable error. And we have to check that this probable error is less than the permissible error. So for carefully cut gear, refer to the graph figure 16.1, module 6. What is the value of E? Perfect. It is 0.03 probable error. This is from the graph of probable error versus module, where the class of the gear is carefully cut gear. What is the value of FT you are getting? Aditya, what is FT you are getting?
Ma'am, actually FP and FT we are getting different values because we have changed them.
For both, you have to
FP,
use same value of M.
one we are getting 5,983 and the other we are getting 8,391.
No, you have to use this 5983 because we are equating this with FB. Use this value of FT now, which we have equated with FT.
FB is 8391.6. Means
FB by
233
using
n square
233 n square
is 8,391.6.
and for FB you are using this formula, right? 233 into 6,
Yes, ma'am.
6 square.
Ma'am, 33 into 6 square, like it's coming to be 8388.
Okay, just a minute.
And ma'am, it's almost same for the another formula like S0Y-MCVB. It is
Yeah,
coming
but there
839.
B we are calculating. So using that formula, you don't get FB. Okay. To avoid confusion, let me go here. So conceptually, we are using that FB should be greater than FT. Okay. And the value of FT is definitely the force required for transmitting power, which is PD by VP. This design power, you are definitely sure what is the value. VP you have just calculated. So assume or get this value of FT over here. This we equate with FB, and from this FB we calculate the value of B. Give me this now. FT is the design power upon VP, which you have calculated as 35.83 into 10 cube by M. And now if M is 6, what is the value of FT?
$5984.04.
Okay, so we are going with this value 5984 Newton.
Yes, ma'am.
So now we are taking FB as this value, and from this value of FB, we have to calculate what is B and whether this is greater than B minimum or not. Because initial value of B minimum was assumed as 10 m. It can be anything between 8.5 m to 12.5 m. And so this value 233 m square, this is again an approximate value. Since m was unknown, B was unknown, in this particular formula, CV was also assumed, B was also assumed. And so we don't rely on this value of FB, but we rely on this value of FT, and we recalculate FB as whatever is this value of FT. And from here, we'll calculate what is FB. So now your B will change.
Ma'am, do we substitute CV as 0.3 or 0.285?
Now this value, the calculated value.
Okay.
Pehle to we were not knowing what is the value of CV, so we assume 0.3. But now that we know, we go with this calculated value.
But
So
ma'am,
FB is going to change. Yes.
233 m square is not matching with the FT. Like we are not considering that, right?
No, now we are not considering that because 233 m square was with so many assumptions. Value of CV was assumed, value of B was assumed. This
Okay.
value was assumed as 0.3, B was assumed as 10 m. So we are now not going for this. Initially we equated this just to get a range of m, whether it is lying in the range of 2.3 to 3 or 5.3 to 6. So we'll stick to this value of FT, not FB.
Okay.
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 Give me this value. B. Now this is telling you that this is not strong enough because this value is coming out to be less than B minimum. So your B minimum value is 51. So to make the beam stronger, your B value should, or it must be greater than B minimum. So we cannot go with this value. You can increase the value of B to 8.5 times M, or you can even go with 9 times M. So what we'll do is, we initially will assume the value of B as 51 because this is not in the safe zone for face width. We'll go with B as 9M. We'll calculate this. If your FD comes out to be less than FB, then we'll increase the value of B. So as of now, we are assuming, because this is not safe, so let us assume B as 51 mm. Now your FB will again change. FT will remain same. FB will change. S0 is same. Y is same. B you have changed to 51. M is same. CV is 0.285. And when we'll be comparing it with FD, this CV value will drop. Abhi, give me what is FB.
Six, 7, 8, 1.
6781. FB is now greater than FT, right? So this is safe. As far as this calculation goes, FB is greater than FT, which is 5984. So this is safe. Now we'll check FD and FB. And then when we are checking FD with FB, this value of FD will be compared with FB without CV. Why? Why will be comparing FD with FB without CV?
FD already include FI.
Correct. Correct. Now that is not required. So we now want to get the value of FD using these parameters such that this comes out to be less than FB without CV, which is what? Without CV कितना है? Two three seven seven six. Two three seven nine six. 23776. Okay. I'm going with 23776. So if now your FD is coming out to be less than this, then our selection is safe. Otherwise, we'll have to increase B. Okay, so with C, E, B and FT and BP known, you have to give me the value of FD. Calculate FI first. Five nine eight four plus how much? FI. One nine one seven six. Is this the value of FI or FD, Atharva? FD. Okay. Give me FI so that we can compare it with others as well. Yeah, girls, where are you? Give me the answers. FI, Atharva is getting 1319192. Somebody please validate this. 18048. Utkarsh is getting 18048. One 8048. Any other value? Utkarsh, this is FI, right? Not FD. You are giving me the value for this 21 VP into this term. B you used as 9M. Okay. Vaishnav is getting 13192. For B as 8.5M, 51 mm. So much variation, 11688. All we want is FD should be less than FB, otherwise we'll have to change. And if this FD is less than FB, we are safe with M as 6. For B51, FI is 11688. I'm changing to what? 11. 11690. To get a total value of 17672. So as long as this FD is less than FB without CV, you are safe. So design for dynamic load is safe. This is not going to fail in bending. Now suppose you get FD value greater than FB. So what will you do? Suppose your FB, the dynamic load comes out as 25,000 Newton. What should we do? Increase B. Okay, now for increasing B, suppose your value is coming out to be dynamic load is 27,000 newtons or 30,000 newton. The value of B could be only as high as 12.5 M. If the difference is huge, you can directly go with 11 times M. Increase the value of B to 11 times M. And if you still feel this is not safe, make it a maximum of 12.5 M. If suppose even with 12.5 M this is not safe, then what? Suppose after increasing B to its maximum limit of 12.5 M, your dynamic load is still not safe. What will you do? Increase the module, right? Yeah, we'll increase the module first. From 5.5 we have taken 6, you go for 7. So the moment you increase module, M will change, your B will change, and your FB will become much stronger. FB will become stronger, but FD will also change because B has changed. So this value will also increase slightly, but then this increase should be less than the increase in FB because here B is coming in numerator and denominator both. FT will also change. The moment module is changed, everything changes. Your VP will change, your FT will change, your FB will change. And if you are simply changing B, your value of FB and this is changing. FD is changing. So the procedure wise, you have to follow the procedure, not because you are in a hurry in examination, so you directly increase module from 6 to 9. This is a wrong practice. So you have to understand the correct practice is initially increase the value of B. You can increase it maybe in 1 or 2 steps. Don't let it exceed beyond its maximum range. And if even with the maximum value of B, you are not safe under dynamic load, then you can increase the value of module. So this is, as I said, is the standard practice. So this is now showing that your gear tooth is safe in bending.
Design of gear.
Design of gear would be same. Gear will have the similar dimensions. Yes, now we have to check for the wear strength. We are not completed, we are not finished with the pinion design. Now we check for its wear. What is the formula? FW is diameter, pitch circle diameter into the face width B into K into Q. DB and B are known. Q depends upon number of teeth on the gear and pinion, which you know. TP is 25, TG is 6 times of 25. So Q you know. For getting the value of K, Give me the value of Q first and I'll tell you what. Give me Q. $1.71. Right, Shravya? Now look here. Now there's two options. One is we assume the value of K from data book, find out what is FW and check whether this FW, the wear strength is coming greater than the dynamic load or not. In that case, it is safe. But then for selecting K, you should know what is the hardness, which we don't know. As of now, we don't know. So the other option is we equate this FW with FV, which means the wear strength is just enough to sustain the dynamic load. We equate this with dB, B, K, Q, get the value of K, and then we slightly increase so that FW increases. क्या समझ में आया? Either you assume K, find FW and check with FD, or assume FW to be equal to FD and find K. So these are two ways. So first way is difficult because for the load stress factor K, you have a table given as 16.6 where the value of K for 20-degree involute full depth is given in terms of the material and BHN. BHN stands for what? BHN. Brenner hardness number, yeah. But since you don't know Brenner hardness number, how do you get the value of K? And so we are going with this way, FW equal to FD, value of FD is known, dB is known, B is known, Q is known, give me the value of K. K is coming out to be 1.35. Now your values of FD are different. What are the values for K? You are getting, okay, 1.35. All of you are getting 1.35. Now for K as 1.35, what is the next higher number for 20-degree involute? What is the material combination that we have taken? Cast iron and steel. What is the next higher value available? Refer the data book. 1.37. So we are assuming K as 1.37. Now you see we have increased K from 1.35 to 1.37, which means FW will be now greater than FD. So from the data book, we are taking K as the next available value 1.376 for pressure angle of 20 degrees full depth for cast iron steel combination. अरे cast iron नहीं था, cast steel था. Our value was for cast steel, not for cast iron. So it is steel-steel combination. Cast steel versus ISO steel. SA grade steel, which has now made a new value of FW क्या हो गया? dB into B into this value of K into Q. Give me this. This will be definitely greater than FD. So you are C. 13,000, and what is FD? FD कितना दिया था यहाँ पर? 17672. So this is safe in where? Is this part clear? What we have done? Unless you say no, I'm not going to explain.
Hello, ma'am.
Yeah.
Ma'am, what is dB? I didn't get that part. And how
dB
we
is the pitch
calculate
circle
it?
diameter. dB is the pitch circle diameter of the pinion. dP है, B नहीं. Pitch circle diameter of the pinion.
Okay.
25 m.
Okay, ma'am. Thank you.
B is the face width. K is this hardness, and Q is the ratio of number of teeth. So it is the wear strength is depending upon what is the size factor, that is the number of teeth that you have selected. Okay. For value of K, you have referred to table 16.6, load stress factor K. These things are very simple when you have a hard copy of the design data book. I'm sure your generation must be comfortable with the soft copy as well. But the fact remains, with hard copy, turning the pages is easier. What do you think? Atharva?
Ma'am,
Yes?
for K, are we not
Yes.
taking carbon versus steel?
Sorry, come again.
Are we not choosing the gear as carbon and pinion as steel?
Gear is
For
carbon.
the value of K.
Gear, we have already assumed is cast steel, and pinion as forged carbon steel. This is what we have assumed, right? Which means ultimately it is steel versus steel. Different grades of steel versus steel.
Okay, ma'am.
It is not cast iron. In the gear material and their strength, you have the material for gear as cast iron, then cast steel, then the carbon steel, alloy steel, bronze, phosphorus bronze. So many combinations are given, but our combination is cast steel versus forged carbon steel,
Okay, ma'am. Yes, ma'am.
right?
Yes,
Yeah.
ma'am.
So we are using the value of K for steel versus steel.
Yes, ma'am. Oh.
And there is one more part left. We have to again check how TG and TP are calculated. TP is number of teeth on pinion, which we assumed as 25. Yeah, we assume 25 as TG for good balance. TP and TG is velocity ratio times 25. That is 6 times of 25, which is 150. Saurabh, you were present in the last class, I guess.
Yes, ma'am, I was present.
Okay.
Ma'am, for Fi, the C value which we took was cast iron and steel, right?
Yes, ma'am. For value of
हाँ,
C, we have taken 8100.
right. बोलो steel and steel लेना था 11800 लेना था
Yes, ma'am.
कर लो edit if you can edit it steel and steel so basically what we are trying to do is understand a complete design procedure. Now I want you to design the part B, the gear pair 2, that is P2, G2 on the same lines. Assume your material, check which one is stronger, pinion or gear, and design that. And submit me the answer on WhatsApp. Aditya, we need to create a WhatsApp group for MD2 with all the students and myself in that group. So let all students ask me as many doubts as you have through that WhatsApp group. Okay, Aditya?
Okay, ma'am, we will create.
Yeah. And the last one is F endurance. Now this is strong in bending we have seen. This is safe in wear. This we have seen. Now we have to check for its endurance strength. So endurance strength is telling us about how many cycles of loading this is going to withstand. And the formula is for the endurance load is SEB, which is the endurance strength, again given in the design data book, into B, which we have taken as 8.5 times M, into Y, into M. SEB is given in table 16.9. For steel, यहाँ पर हमने क्या BHN, what BHN we have taken with K as 1.375. This is safe in wear if the value of Brinell hardness number is कितना है for 1.376. Either you have 300 as BHN or 250 and 350. So this is safe in wear if the Brinell hardness number for gear and pinion is 300 each, or it is 250 for gear and 350 for pinion. This you have to mention. And for this BHN 300, what is the reverse bending endurance limit in megapascals? Table 16.9. $526, right, Piyush? So use this value, 526 megapascals, into B is 15, into Y कितना है? Into M is 6. Check what is your endurance strength. This should be greater than your FD. There's a Y value for pinion, 37. $59,000. 59,553, which is pretty much higher than FD. And so this is very safe in endurance. Normally, if it is safe in bending and wear, this will always be safe in endurance. But as a correct design practice, you have to check for endurance also. Now ask me doubts if you have, else I'll quickly go through the entire design process once.
Ma'am, so for this pair, we will not be designing for the gear.
No, if it is pinion is safe for all these loads, gear is definitely safe because S0 into Y is higher for gear and gear is having larger diameter and it is rotating at a lower RPM. So
Yes, ma'am.
this design completes here. You have to design only for either pinion or gear. And the answer ideally should be given like this is pinion, this is gear. Module remains the same for both pinion and gear. And you have to give the number of teeth, which is 25, 150. You have to give the pitch circle diameter for both 25 into 6 MT and 150 into 6 900. Then you have to see the give the addendum value, which is all usually equal to M. You can give the addendum value if you remember the formula 1.57 times N. You have to give the material, carbon forged steel, whatever grade, cast steel, whatever grade. You can mention S0. You have to give the face width, which will be same for gear and pinion. What else you calculated? BHN. You have to give the BHN for these two materials. So accordingly, you have to, this is your complete design. So when I'm asking you design a pinion and design a gear, you have to design only one of the two. Only one of the two, because whichever is weaker, if that is designed and if that is safe, then the gear is definitely safe. You should give N. PP will remain same. You should give N. This is 1440. And ये कितना है 240. Yeah, value of K is indicating BHN. Wooden hardness number. Okay, so a quick recap of what we have discussed. We'll have one more question in the next class for this per gear design. Ask me or interrupt me in between if you have any doubt. So for this particular problem, we start with the velocity ratio. I'm not explaining this part again. We get what is the design power. From the design power, we have to get what is the value of FT. And for FT, we'll need design power and the peripheral velocity. For peripheral velocity, we need the diameter of the pinion. For diameter, we have to take the number of teeth on the pinion, the smaller of two. So normally for good balance, we take this as T, module V, take it as M, find the pitch circle diameter, M into T, find the peripheral velocity, get the value of Ft, which is PD by Vp, and this will be a term, something upon M, keep it in newtons because everything is going to be in newtons. Then we select the material. Normally we'll go with pinion with a higher strength because this is rotating at higher RPM and this is smaller in size. So we want this one to be stronger when we are selecting the material, but the design depends upon S0 into Y, where S0 is giving the strength and Y is the Lewis form factor, and this product is telling about the entire tooth with its geometry, number of tooth and material, whether this is stronger or weaker. And we got the value that pinion is weaker, and so we are designing for pinion. Once you design for the pinion, the same value of B and M would stand true for gear as well. So we have to design either for pinion or for gear, not for both. Then we start with what is the beam strength by this modified Lewis form equation with CV. Initially, because M is not known, Vp is not known, so we assume the value of CV based on the RPM of the pinion, which is 0.3. Value of B is also not known, so we just take some range between the minimum to maximum, that is 10 times of M. Value of Y you know, value of S0 you know, so this is an approximate value of FB. Because CV is approximated and B is also assumed value, it is not the exact value. And to get a range of M, we equate FB with FT. So ideally FB should be greater than or equal to FT. By equating this, you get a range of M as 5.36 and next standard value available in the data book is M is 6. From here, we get the value of Ft, and this will be the value of Ft or Fb. Once you get M, find out what is the pitch circle diameter, what is the peripheral velocity, get the calculated value of Cv, which is 0.285, which is coming out to be the less than the assumed value. Now with this value of Ft, which now we are taking as Fb, now we'll check what is the value of B coming out to be, because earlier the B value was assumed. So we have to calculate whether the value of B is coming out to be greater than B minimum or not. And if it is coming out to be less, then increase the value to whatever is the minimum value of B. Here, as I said, instead of 8.5M, you can go with 9M or 10M. But as a designer, you increase the face width and the size of the gear increases, the weight of the gear increases, its strength is increasing, but the cost is also increasing. When the size of the gear increases with the face width, its weight increases, the weight coming on the shaft increases, so the shaft should be stronger. And as the weight of shaft increases, the bearing which you are designing to support the shaft, that also becomes costlier. So we are always trying to minimize or economize so that we have the minimum size, but it is still safe and strong enough. And so a good practice is go with B minimum if it is safe. If it is not safe, then we increase the value of B. Next step is get the dynamic load, get the value of C for steel versus steel, which is 11800. Get the probable error for the given class of gear. Check if it is less than permissible error. For this value of VP 11.3, if you check the permissible error, it is coming out to be 0.04. So if your probable error is less than permissible, then it is safe. With this value, you are getting the value of FD. And with this new value of B and M and calculated value of CV, you again calculate what is the beam strength FB with CV and without CV. So FB without CV is coming out to be 23,000 Newton. We want our dynamic load to be less than this. Now here in this calculation, you might get some error as in depending upon what is the value of E and to what decimal places you are solving. Some of you might end up with 17,000 or 18,000 or 16,000. So as long as this is less than FB, we are quite safe. The moment this increases, or this is more than FD, then you have to increase the value of B, make it 9M or 10M or 12M. Don't exceed beyond 12.5M. If you exceed it to 12.5M and if this is still not safe, then we increase the value of M. So in this particular problem, we fortunately got FD less than FB without CV. This you have to keep in mind. This should be without CV. And then you have to check for its wear strength. Wear depends upon what is its pitch circle diameter, face width, hardness, and Q. Now hardness will again depend upon the material and BHN. BHN is not known. So instead we equate FW with FD, get the value of K, and from the data book we refer to next higher value of K. So the moment you go with the next higher value, FW already increases. So when FW increases, your condition FW is greater and FD is satisfied. And this is safe in wear. Write down what is BHN for gear and pinion. Check for endurance strength. Endurance strength, again, these equations are given. The endurance strength SEB for the given hardness, you can refer the design data book. Check that this value is greater than FD. And then you present your final value for pinion and gear. So this completes the design of one gear pair. On the similar lines, I want you to go with the design of second gear pair P2G2, where RPMs are given and design power is given. Come out with this kind of answer and then you can post your answers on the WhatsApp group. If you have any problem there, you can ask me. So next class, we'll solve another problem on this gear design where some other data is given. So that's all from my end. Okay, any doubts?
Ma'am,
Yes.
why did we initially assume B is equal to 10m?
B lies in the range of 8.5 m to 12.5 m, which means we have to assume somewhere in this range. You can start with 9 m, you can start with 12 m.
But
Anyway,
if finally we want B to be the lowest value, then if we start our assumption with 8.5 m, won't it be better?
You can try it once, not a
Okay.
problem. But this is to make the calculation simpler, we are going for 10 m. That's it.
So, but if we take different value of B, then we will get a different value of M. So everything will change.
Yeah, but finally you are going to check for the calculated value of B after calculation should be greater than B minimum. That is enough.
So there is a chance that if I take some other value initially and use some other procedure, my
So after
answer will
module,
come
instead of
different from this.
5.3, you will get 5.4 or 5.2. इतना difference आएगा.
Okay.
It won't create much of a difference, but you can definitely try once.
Okay, ma'am.
Okay. Yeah. Anybody has any more doubts? Please feel free to ask because this is a very important topic. Rishabh, Rushika, Arshil.
No doubts.
Okay. Shivesh. Okay, well, so we stop here then.